Okay, thanks for coming along to our October, and I can't believe it's October already, presentation night. Now, what the committee decided was very much a bit of a hybrid night, and what that means is there'll be a bit of a presentation, a few bits and pieces. We'll take you on a bit of a chronology, and then we'll open it up to people's experience with printed circuit boards. So that's the sort of the style. And a huge thank you to Sean, who set up our high definition Elmo here. So what I'm going to do is push things through the Elmo so you can actually look at what's going on. Now get my cheat sheet here. So to start at the very beginning, some of the earliest printed circuit boards that are known actually started back in 1903. They tried to put foil conductors on things. So foil as in, I assume, copper foil. And try and plate it onto things. Now that was not that successful from what I've read. Edison experimented with plating or putting some sort of metallic foil onto linen, and I think that might have been part of his experiments with trying to find the right globe filament that lasted. Then we jump to World War II. And World War II, there was some experiments done with what looked like the precursor to printed circuit boards with proximity fuses in bombs. So when they get close to something, they go off. And the reason they went with printed circuit boards was to make sure that the components could survive the acceleration of being dropped, because most of their electronics couldn't. So they've created these printed circuit boards. So that's 1940s. 1956, the US Army perfected laminating copper onto material. And so what we now know as our copper-clad, this is fiberglass, copper-clad fiberglass or copper-clad phenolic, which is the precursor, some precursor to plastic. That sort of board, because we're talking there in that's probably a 50s or 60s board. There is another board here. Thank you to Richard too, VK7HH, who supplied these two boards, and I'm glad he did, because it was a gap in my chronology. So it's these sort of boards that we're looking at. All through-hole plated, through-hole components. We then go to around the early 80s, where they started to perfect printed circuit boards as we know them. So that's when I started to get involved with printed circuit boards, which was 1982, and I was using this stuff. Now this is Bishop. If you've this is, and these are obviously dual inline IC type stencils or templates. Now, who wants to have a bit of a guess? Oh, you can probably read it on there. It's all 2 times. That's 2 times the size of the IC, dual inline normal IC. Everything was done in 2 times. There was tape. I'll show you. There were. Here we go. We hand that around now. This is one that's done in Bishop tape. So, and I'll get one for the. There we go. For the Elmo. this is, you'll notice, and in fact this is a good idea. That's the 2 times printed circuit board that I created. You did it on graph paper, 0.1 inch imperial graph paper. Everything's imperial in printed circuit board speak, so everything's at a 0.1 spacing. You do that 2 times. You then, that printed circuit board was then photographically reduced by half to what you see in here, which is the actual negative, the negative of that board, which is real size. And you'll see, actually you probably can't see that on there. There is a whole lot of touch-up that's been done with an ink pen before the board was printed. I'll hand that round. And how did the board look? That's the board there. So this is an 8x8 LED display. If I look at the date, it's July 1983. So this is a 8x8 LED display. One of the things I'll hand around is the printed circuit board is on a display. It's being driven with a whole lot of wire-wrapped prototype board. So this is the precursor to printed circuit boards. For those people who don't know wire wrap, this is the precursor to printed circuit boards. Basically you had a little tool, you had Teflon coated wire. Those pins on here are square, so they've got a really sharp edge, 4 edges. You'd turn the Teflon wire around it and it would pierce the Teflon coating and connect to the wire inside. That's wire wrap. And there were whole computers, can I just say, whole computers. I remember seeing a Burroughs computer, literally the whole thing was wire wrapped. It was just remarkable, absolutely remarkable. So that's the 1980s. Now, Altium. Who remembers Altium? Now, okay, Hayden. I'll just say, we've got some prizes for the best questions. Now, they have to be good questions. Got some really, really good prizes.
Who was Altium?
No, that's not. Altium was an Australian company. It was actually an Australian company. In the 80s, it was Altium. By about 1990, it became Protel. Now, lots of people have heard of Protel. And so it was an Australian design for circuit boards. Now, and that meant we went to, let me find a board. It was Protel then Altium, Justin. Yeah. The other way around. Yeah. Oh, okay. No, I've got that around the wrong way. Okay.
Wasn't Protel
Tasmanian. Yeah. There was a Tasmanian component to it. So here is now 1986. So 1986. This is a Protel design board. You'll notice it's double-sided and it had plated through holes. So we've gone to and it's 2 times. So this is twice the size that it needed to be. It was photographically reduced and then printed and plated through holes. Precursor to plated through holes were rivets. I've seen boards and they're phenolic boards that actually it was a 2-sided, it had copper on both sides, and instead of the plating through from one side to the other, they actually put little rivets in and pushed the little rivets together to connect one side to the other. I've seen that, and they actually then put the rivets holes were big enough to put a through-hole component through, and then you'd solder it in as well. So that was pretty cool.
So plated through holes, is that what they call vias or vias?
Vias,
no.
well and truly.
Okay.
And it's a really, It's a really involved process if you've ever seen it. I was fortunate enough to see NTEC, which became IMP in South Australia, were our printed circuit board manufacturers in South Australia, and they took me through the process from go to woe, even the photographic side of it, and the vias, and they drill the vias. They have a whole registration system so that the one side lines up with the other side. So when you drill the hole, it goes through, and then they literally need to connect to electroplate through that hole, and it's just phenomenal, the amount of work. And for what we were buying the boards for, it was crazy, absolutely crazy. So what they then did with that was they would reduce it down in size. Now this is not the same board, but it'll show you the process. There's a positive of the board that they would create. They'd shrink it by half. They'd then do a negative of it, and you'll see there is paint all over that. There was obviously scratches and all sorts of stuff. So they touched that all up. They would then be able to print onto the copper that had photoresist on it. They'd spray photoresist on it, dry the photoresist. You had to dry it in an oven, and it was all done in safe light conditions because it was light sensitive. And you would then put that onto the board and expose it for X amount of time, and then you'd put that board into developer, much like a photographic process, and it would create the pattern on the actual printed circuit board, which you could then etch, and I'll go into the etching process in a short while. The other things that they would do, and this was if you could pay enough for them, you could have a solder mask. Now I haven't got a solder mask here, but a solder mask is just the process of just the pads are actually exposed, so that when you put it through a wave flow soldering machine, it's only the pads that get exposed to the hot solder. The rest is covered. And in fact, Sean, I'm going to put. So you can see on this printed circuit board, the only thing that is actually exposed, and you can see the pads, etc. And so that's had a solder mask put on it that only exposes the bits that you want soldered. So yeah, that's a green solder mask. Then you've got a silk screen. So I'll hand the board around. That's the actual board that these come from, and you'll see the silk screen has the wonderful label on it, which tells you where the components go, etc., etc. That's a bit. Come down here. It's just a bit bright. I don't quite know. Oh, there we go. You can see the silk screen that was put on here. So where the components go and what the connectors do and all sorts of things. So, and that's just what we call a tin plated board. So it just came with a tin plate on it, so it's not bare copper. And that solder mask, the same thing was done. There was a positive, and then there was a negative done, and the negative was what they used for the silk screen. So they transferred that to a silk screen, which they then inked with ink, put the ink on after registering it. So it was just a huge process, absolutely huge process. We went to double-sided boards. Now wave flow soldering machines. Wave flow soldering machines was a absolute revolution. Before that, literally there was a large bath of molten solder that the board went through, and then somebody came up with the idea of, hang on, if we actually use the solder as the rotor in an induction motor, that's how it worked. So it was a shorted turn of solder. They could actually push the solder into a wave. So you had this wave that the bottom of the board went through. So it just touched the board as it went through, and you regulated the speed to get the heat right so that it soldered each of the components. And we had a wave flow soldering machine at the company I worked for, and it took literally half a day to spin this thing up. So you got everything ready, and then you turned on the power to it, and once everything was molten, you would start this motor up, and it would create this wave, and you then do some test boards, and but that wave was then used for surface mount components, because what they went to with surface mount components was you could glue the surface mount components onto each of the spots, and you usually get a machine to do that, pick and place machine, and then it would go through the wave flow soldering machine. The glue was strong enough to hold it even with extreme heat, and it would solder each end of the components of the surface mount. 1990s.
So the whole board got submerged in the molten solder.
Well, the underneath of the board, or the surface that was exposed. So it went through, and it would probably be, there'd be 3 or 4 mil either side of the board. So it was a significant. It would probably be about 10 mil that's actually exposed on the board to the molten solder as it went through, and it's moving all the time.
But if the surface mounts, if the components are on the top.
No, you turn the board over. That's why they're glued. That's why and if they're on both sides, you glue them on one side, do that side, turn them over, do that side. Yeah. 1990s started to go into 4-layer motherboards, 4-layer boards. So you had 2 internal power layers, and then you had a signal layer on the bottom and the top. And you had through vias that would have clearance holes in the power layer, and it would go through from one side to the other. They were pretty special boards, and that's a multi-stage process. And early on, they were not that reliable, but they perfected the process. You now get up to, I think, 8 or 10 layer boards, which have internal vias. So between one layer and another, you never see there's actually a via in there. It's just it's off the show. The company I was working with, we went to 4-layer motherboards. That was our most, and that was a nightmare to troubleshoot. That was just off the show. So we moved to and RF PCBs. You've probably seen them. RF PCBs, if they're up in the microwave sort of area, the substrate is not fiberglass anymore, because fiberglass creates all sorts of other effects. They can be ceramic. There's other materials. There's a whole bunch of materials that they use. They're also creating filters and strip line filters and mixers and all sorts of things on the printed circuit board, which is just phenomenal. And in fact, the thing that was taken apart the other day, it's worth a look at, because the printed circuit board in there has a whole lot of little mixing elements in it and all sorts of RF trickery at the gigahertz sort of stages. So it's worth a look. And they do all that in PCBs, well and truly. I think the board's still in there. Yeah. Just have a look at this is state of the art RF sort of technology. So 2000s. Okay, get to 2000s. How many people have used press and peel? No? Okay. That's good.
The bishop stuff.
You can still buy it from and in fact that's what you buy from JCar. It's fairly expensive, can I just say. That's $45 for 5 sheets, but you can get an awful lot on 5 sheets. That's what it looks like, and in fact I've laser printed one. It's a board. It's a pico ammeter, so an ammeter for pico amps that I designed. Hasn't been ironed onto the board yet, but that's what press and peel looks like. the beauty of press and peel is you can design the board in your favourite application. There we go. There is a piece of press and peel. Now you'll notice I've got all sorts of little bits of press and peel here because you can actually, if you're really careful, stick this to a piece of paper and put it through the laser printer again and hold your breath while it goes through because you stick it on there with tape. But you can use your favourite design, KiCAD, or I use ExpressPCB, and you can design it, you can print it one-to-one, which is like this, and you'll notice here there is a whole lot of ways of printing it. You'll notice the lettering here, the name here is around the wrong way. When you print that onto press and peel and then put it onto the PCB, it comes out the right way. This is a PCB that I designed literally within the last couple of weeks. For those who were here on the DATV night, this is the Speedo, the GPS Speedo that I made up. That is a PCB that puts all of the components together. It was done with press and peel, and in fact there, just to prove it was done with press and peel, there's the press and peel sheet. Once I have put it onto the clean copper, and yes, I use an iron. This is one that I rescued from the skip as my wife was throwing it into the skip, because it still works.
Because they had no press and peel on it.
Well, can I just say, you need to be fairly careful with that, because if you're not, if you go to the linen setting on the iron, that's what you end up with.
So it's press and scrape.
And then you need to scrape it off the back of the iron. So you need to get your temperature just right. But what it basically does is the black toner that the laser printer puts onto the film, what you do when you put the iron onto it is it melts the toner. Toner is just a really fine dust that is electrostatically put onto the page, and then it goes through what they call a fusing roller, which makes it solid so it doesn't come off the page. What you can do is, if you reheat it, is you can transfer it onto copper, and that's basically the press and peel process. So you need to get the temperature right. And the temperature sort of varies per different types of laser printers, because different types of laser printers use different temperatures for their toner. But once you work it out, you can do this sort of stuff. And that board there, it took me probably, I don't know, an hour to get to that point, and then another hour to get to a PCB. It's really quick for prototyping. That's the beauty of it. Press and peel though is pretty expensive. That's why I keep the bits, and you tend to make sure that if you're going to do one or two, if you're going to do one, you probably do a number of them like this. And I've got a whole lot here. This is I don't even know what this is. Oh, that's our optical transceiver that we built as a kit. That's actually a Reast kit that we built, that Mike Groth designed. That's the transmitter receiver. That's the broadcast box. You'll notice there's lots of them. You tend to do this sort of thing. I use then you can use a whole sheet of press and peel and do it all in one. So you there's all sorts of things in here.
When you get a board off though, it's not going to have any resist mask, is it? It's
No.
solder.
No, it's purely you end up with a board that looks like the one that went around. Yeah. It's copper. It's nothing else. So if you want solder masks and you want silk screens and all sorts of things, speak to your friendly China person, which Sean's going to go into. So that's the press and peel process. If you want to know any more about it, please come up and have a look. There's plenty of examples of it being used, and it does work. It actually does work.
Justin, when you press and peel, do you preheat your copper boards? Because I often, whenever I'm using, or pretty much always when I do press and peel, I need to come back and then touch up on the copper board. I don't get beautiful transfers like you seemed to be getting.
No, neither do I, Lance. Can I just say, in my little kit here, who remembers Dalo Pens? I actually still have 2, and guess what? They still work, and they would be, I don't know, 20 years old. They actually still work. And
Do you draw on the copper?
You draw straight on the copper.
I use them.
So you can just draw straight on the copper, and in fact, just bear with. Oh, there we go. So that the speedo, I did. Oh, come on, it's really sticky, that stuff. The speedo here is a piece of copper that I have actually transferred. I did 2 of them. And you'll notice, Lance, there's a whole lot of touch-up on that one because that was a really crappy one. That was actually a really crappy one. That's the one I didn't use. I etched the other one. But the key thing with press and peel is it's all about speed to product. If you want to do it really quickly, honestly, the press and peel process with your favourite PCB design software is probably the way to go. I drill it. I use a Dremel, so it's a Dremel is a really you can get 10,000 RPM out of a Dremel. That is for really small, sub-millimetre, 1 millimetre drills. You need that speed, or you'll just keep breaking drills. That's so, yeah. And I've got a little container full of sub 1 millimetre drills that I always have to use a vernier calipers for to work out which one it is. But yeah. So, and I literally drill it manually. I go through and yeah, and that's exactly what I did with that board that was circulating.
Like with a power drill, or do you have a press?
I actually have a press for the Dremel. There is a little press that came with the Dremel that it doesn't move the drill, it moves the table up, which I thought was a bit crazy. But when you actually sit there, it actually works quite well. You just sit there whizzing the table up and down. So, and the copper etched pads centre the drill where the hole is. So your spacing's not bad, unless you let the drill wander, which is a bit of a problem. But anyway. Oh well, and speed, honestly, as fast as you can get it. Now, how do I etch the boards? We get to the boards. You'll laugh at this. I have a little container which is. I'll hand this around. It's okay. It's not dangerous. Just don't open it. Ammonium Persulphate. I don't use ferric chloride. I used to use ferric chloride. Ferric chloride is horrible.
It's black.
And it stains and it doesn't come out. Ammonium Persulphate is the other way of doing it. The problem with ammonium persulphate though is you've got it needs to be at 75 degrees C, and you need to keep it at 75 degrees C to make it the most effective etch. 75 degrees C. I usually boil a kettle and have it have boiling water into the ammonium persulphate, which then cools down to about 75 degrees, and I put the rest of the water around it. So it's 4 to 5 minutes and you've got an etched board. And just have a look at the label of it, and it's still perfectly alright. The label is Dick Smith. came from Dick Smith. It's all
In
sorts
the
of
era pre-used by dates.
Oh, well and truly. And it's still perfectly all right. I had to break it up a little bit, but it went a bit hard because it absorbs water. But works an absolute treat. And
Do you save the dregs or
No.
is it one use?
gets poured down the sink, well and truly.
Sink? Did you hear that, man?
The what happens? It progressively, it's clear liquid, and as it progressively etches, it goes blue, which is the copper that's coming out off the board, and it can be pretty quick. If it's up at that 75 degrees and you maintain it, it's 2 or 3 minutes and you've etched the copper off.
Do you need to agitate it or anything?
Yeah, you all the time. So yeah, so that's how I etch the board. I haven't used ferric chloride for absolute ever. Yeah.
See, my problem is I bought the ferric chloride, but in a big thing, and so yeah, like that lasts forever. The big thing will do me and my kids and my grandkids until they die. So
Or they die from it. Yeah. So yeah, but anyway, that's Hayden, do you want to
Yeah. Do you want to see? I've got a couple of things
Yeah,
I
yeah.
could probably show. I should go through the process of what I used to do. Not as exciting as all of this stuff. So about 16 years ago, more than that. 16 years ago, I was an electronics apprentice at UTAS, and part of my job was doing PCB. We would have a students come to us and would say, hey, we've got this project and we need to build this circuit up. Can you build it for us? So I'd use Altium, create the circuit, draw it all up, design it, put the layout on. There wasn't much auto routing, it was all manual at that time. Print it out and then go and etch it. So as part of the process would be using Altium to set out all the components, all the values. Altium also had a simulation thing in it as well that would check to make sure that everything was right as well.
Against the schematic?
Against the schematic, yep. And this was after Protel, and it was also just before boards were quite common and easy to make through China, so we had to do them ourselves. We used to get quotes for like a place in Melbourne to do them, but it was like $500 for like 5 boards, which was ridiculous. So we had our own in-house thing. So what we did was we had the transparent paper, and we had a laser printer. So we do everything, lay it all out. We also did double-sided boards as well. So we'd have to put vias in and do everything. Single-sided boards were fine. So we'd print out on our transparent paper a single-sided board, which was easy. Double-sided, we'd have to print the top side and the bottom side, line them up manually, and then tape each side enough so that you were lined up so that when you drilled a hole, it went through both sides of the hole on the board. And then what we did was we took the board, we went downstairs. We had this in the bunker thing, this etching facility, and we peeled back off the copper. It had like a a plastic cover on the copper that you'd peel off, so you'd expose the copper. And if it was a double-sided board, you'd slide it between the two transparent pieces of paper, and we put it in a UV box, and we'd expose it to UV light for probably 10 minutes. And then what that would do is that would then expose the tracks that were, it would hit, the UV would hit the board, and everything that wasn't covered by the tracks on the printed bit of transparent paper was all was left, so you'd have your tracks. And then what we do is we drill holes in the top of the board, stick it in the etching tank, which was ferric chloride, and we had a 7:1 ratio, I think. No, that's not right. We had 7 kilos. That's right, 7 kilos of ferric chloride to 50 litres. We swapped out the tank twice while I was there in 4 years. The first time we did it, my boss at the time didn't realise how volatile ferric chloride was and put the entire 7 kilos into the tank and came back in about 10 minutes and was boiling because it gets hot really, really quickly. So what we did was the next time we did it, we just poured in 1 kilo at a time, and we'd have to wait half an hour. So it took us a couple of hours to fill this tank up. Then we had pumps. So we used to mount the board in the tank vertically, and we'd have pumps on the back and pumps on the front, which would spray the board. And we had to replace the pumps one year, and we put these. We ended up having to plastic weld these holders so that we could hold the pumps in, because they weren't designed for the tank, so we had to make them so they were designed. You can't use metal plates because the metal plate will just rust away and it'll disappear. So anyway, we built all this up, we put all these pumps in, worked awesome for about 2 weeks, and then I went down there one day and turned it on, and all I could hear was the motors running, and there was no ferric chloride or no water being pumped through the pumps. I'm like, what's going on? Pulled it out. The shafts were metal, and they're just completely gone because ferric chloride's highly corrosive. So we had to pull the motor apart and build a plastic shaft on each of the 6 motors so that they wouldn't rust away. So that was interesting. So anyway, you'd spray the ferric chloride, you'd leave that for about 10 minutes, and all you'd be left with is what you would see all of the coppers disappeared except for the tracks. And then you'd go over the top with methylated spirits to clean the tracks off, and then spray it with lacquer, and then sit down at the drill press, 1mm drill all the holes manually, which was a real pain. It took a lot of time. Guillotine it up, and that was your board basically, and then have to populate it and then test it. So for a whole process for building a board sometimes could take several days, depending on how many boards we needed to make and how complicated they were.
So you soldered through the lacquer?
Yes. Yep. So we sprayed the board with circuit board lacquer as the last part of the process before drilling, and then we'd solder through
so
the
heat
lacquer.
of solder just burns the lacquer away.
Yeah. We didn't spray a lot of lacquer. That was just to sort of protected. It was just like a clear, and then on the other side. But yeah, we just burned through it, and occasionally, because most of this stuff was sort of prototype, you'd find like errors or something, and you'd have to like fix it while you could. Number of projects we did. So the ones that I can think of that I designed, we developed a robot out at Mona, which it sat with these motors which could move in any direction. What are the wheels? I can't remember. They had they got wheels that turn in one direction and rollers that run in the other. Yeah. And when you drive them in a certain direction, they can move any way they want. And what we did was we put it in this plinth, and the idea was David Walsh wanted exhibits that would follow you around the room. So we put in proximity sensors that would detect when people were nearby, and it would move towards them until it got to a certain distance, then it would stop. So I built all of the PWM controllers for the motors, and I don't think I did the logic stuff. I think someone else did the logic stuff. My boss might have done that. He wasn't too impressed with that because for some reason he didn't like it, and he's a very weird individual and hard to please. But the lady who's his partner, she thought it was cool, so we did that. Also built some stuff for strain gauges on the hull of the Incat catamarans. So one of our researchers, he was doing measuring the effects of hull strain hitting when waves would hit the hull of the Incat. So we had to build lots and lots of these data loggers and strain gauge interfaces so that we'd mount these tiny little gauges on the hull stuck on the aluminium hull, and it would measure how much strain they were getting. A couple of other projects. I'm trying to think of what we did. We did some data loggers and GPS interface boards for Antarctica. So they sat down, and we built them in these boxes and shipped them down to Antarctica, and they buried them in an ice shelf to see how far they'd move over like 5 years. And we were a bit worried about how long they'd last. I think I built all of them. I think I built 12 of them that got buried, and I think 10 of them come back good, which they were only expecting a 50% pass rate. So the fact they got 10 back was good. I don't know what happened to all of this stuff. I marked my name down on a lot of stuff to keep track of it, and last time I was in engineering, I found one of my boards that I made for something, but a lot of stuff I can't even remember what it was for or what I made it for. But yeah, it was pretty interesting. Yeah, it was frustrating but interesting. And I was just before we started, I found an online Altium opener. What do you call it? Online web viewer, and I found a couple of schematics that I'd designed up, and a couple of overlays and that. I don't know if this will show up or not, but no.
Way too.
But yeah, it was basically design the circuit. Actually, I could probably zoom up on that. No, won't let me zoom. Oop. So yeah, you basically design your circuit up and then lay out your PCB. So again, that was all sitting down at a computer trying to work out where to run things. So all of those blue lines, they're all bottom layer. And a lot of the stuff I try to make a single layer board because it's just much easier to make and you can play around with stuff.
Try that, because that'd probably work.
It's
high contrast. Yeah.
Yeah, so that's the bottom layer is the blue, and with this the red one's technically top layer, but it was only a single layer board, so I just put in links in there, so that I could only do it with one layer, and a lot of the time, you can do all this now with JLCPCB, Eagle PCB, or whatever the other ones, and you just click auto route and it just does all this for you. But this is sort of back in the day when Altium had an auto route function, but it wasn't quite perfect, and you'd set it off and it would do all sorts of weird things. So what we used to do is I used to group things into certain areas. So I'd have power supply in one side of the board, then logic usually in the middle, but obviously everything's built around the IC in the middle. Logic, signaling, and power supply. And they were the main three, I think. Oh, and interfaces. All the interfaces usually would sit around the outside perimeter of the board. And that's what we generally tried to work towards, and then build our boards up from that. So, yeah, it was interesting. I'd forgotten everything to do with Altium and everything to do with all of this, so I wouldn't be able to do it now. But yeah, it was pretty cool, pretty interesting. Yeah. Try and think of another.
Lots of people online, Hayden. Been a while since I made a circuit board with etch resistant ferric chloride. That's from Darren VK7HH. We've got Andy, Ron. We've got Peter, David.
Ferric chloride in that quantity as well is just it's a horrendous smell, and it's hot, and I've probably got some sort of ferrite chloride poisoning that's probably going to kill me in like 30 years or something. But because I never used to wear a mask, which was probably bad too. Yep. But yeah, it's pretty. You'd never use it now. It's pretty bad stuff. And yeah, it's black. It's like trying to think what it's like. It's like this dust, this black fine dust.
Coke.
And you'd pour it in the water, and you'd literally see the water start to boil.
It's an oxidizing agent.
Yeah.
The same as that. The ammonium persulphate's an oxidizing agent. A ultra oxidizing agent. You don't want to get on your skin.
No, and like what I said with those pumps, it was 2 weeks. They didn't even last I didn't use it very often in that 2 weeks. It could have been even less than that. Yeah. And the shafts and all of them had all dropped out into the bottom of the tank. And of course, they wouldn't have been in the bottom of the tank. They would have just disappeared.
No. Well, the metal, the iron of the shafts was in solution.
And I think from memory, when we had to dispose of it, we had to call someone, like some chemicals place up to come and collect it.
No.
Because if we did pour it down the sink, it would literally get rid of all the pipes because they were all
Correct.
metal pipes.
Overflow we had then.
So yeah, we didn't pour any ferric chloride down the sink because that would be bad. But we did have to call someone in to come and remove that. I'm trying to think if there was anything else about the process that made it difficult. But yeah, nowadays you'd probably design the board up yourself and just get China to make it, basically. Just be easier.
Everything goes to China.
But yeah, I finished up in 2012 and I was still making them then. So, but yeah, there was some other interesting bits that I did make. And like today, you do something completely different. We had a sort of similar to my current job. We had a display screen out in the foyer of the engineering building that would display like digital signage. And whereas now, what we would do is we'd just plug in like a Raspberry Pi or something or some digital signage player and do everything over Ethernet. We didn't have kind of that back in 2008. It was kind of, we're still developing networks and stuff, and we didn't really have all that. So I developed this system where we would send a video signal down an Ethernet cable to it, and we ended up, we wanted to be able to switch the screen on and off on a timer. So what we did was we built these interface boards to send a 1 kilohertz tone from LabVIEW down this audio cable to the other end, and then I built this circuit that would listen for a 1 kilohertz tone. When it heard the tone, it would then switch power to a 5-volt solid state relay, turn the 240 volts on and turn the screen on. And that was all powered off a PC back in the node room somewhere that used to turn the screen on and off. And yeah, it was all ridiculously overcomplicated for what it should have been, but that's kind of what we did.
Work.
Yeah.
Love it.
Yeah.
Good stuff. Any questions for Hayden? We've got one reminiscing, bringing back memories. I still have a Tandy-powered PCB drill and press. That's from Darren, VK7HH. And Tricky. Tricky's in Waratah right at the moment, so shout out to Tricky.
Yeah, Tricky. Yeah, I forgot you don't have a mic. The one thing that was really frustrating was when you'd go and etch a board and then you'd go to drill it and the holes didn't line up on each side. Or if you'd skewed it and you drill half of them and then you get to like one corner of the board and it doesn't match up.
All too familiar.
Because you're lining up the two transparent pieces of paper and they have to be perfect, because even when you separate them and you put the thing.
We used to drill two holes and put wire through to make sure that registration process was right.
Yeah.
So there was already two holes in the board before you exposed both sides of the board.
So our UV box, right. I just remembered our UV box had a compressor in it, and it had it used to we'd used to compress air into it to blow up both sides of the light box. Yeah. Because what would happen is if you put it, we didn't have like clear glass in it, so it would, if you had clear glass, then there was a chance that what would happen is it wouldn't line up properly. So what we did was we put the board in and you'd put the light box down and it would literally squish the two bits of transparent paper together so that they were still aligned. Okay. And then we'd lock it and it would gradually like lose air out of it until it was perfectly flat, and then it would just expose from there on. And 99 or 95% of the time, it was pretty good.
It was okay.
But yeah, the rest of the time, not so much.
I love it.
That's why I used to like making single-sided boards, because I didn't have to worry about the other side.
Tell me about it. Cool. Yeah. Okay. Sean.
Hey. Okay, just get a few things here. Sorry, guys.
Now we move into the modern era.
well, let's see. Okay, so good evening everybody. For those who don't know me, I'm Sean, VK7WTF, and WTF is a very important part of making circuit boards, as I'm sure you've all worked out by now. Justin gave us a very good rundown of how you did things back in the days when you had access to commercial tools and someone else was paying the bill. So very jealous, very jealous. My entry was kind of like the opposite way from Justin here, doing it myself and then getting better and better tools as time and budget and, of course, progress comes in and makes things easier. I'm sure everyone's seen one of these things here. It's called a breadboard. My advice to you all is be very careful with these things. If you can, avoid them like the plague. They used to be a good idea, but a lot of cheap manufacturing has put components in there which tend to corrode. And the reason that board you see has no parts on there is because I found out partway into a project there was a bit of rust going on underneath the plastic and contacts weren't as good as they should have been. Moving on from this kind of technology, a bit of a step up, bigger and better. This little beauty here, courtesy of our friends at JCar. You can buy these in small component strips and clip them together if you need bigger and bigger boards. A great way of getting things working, but again, scale becomes a problem, and there's a beautiful board here that Justin has a lot of wire wrap soldered on the back. Love it, very, very nicely done, but I'm sure a lot of caffeine and hair pulling went into making that work, so I'm impressed. Moving on from these, many people would have seen, where did I put it?
It's on the bread.
Yeah, that's all.
Yeah. As money gets better, many of us may have seen these beautiful things. I couldn't find any Dick Smith hardware in my box of bits and pieces,
Radio Shack.
but Radio Shack, of course, next best thing. Nice quality boards, beautifully made, and sadly no longer available, so that one's going to stay in plastic as a...
Available from JCar, but in a different form.
Yeah, but these ones, I think, when they were manufactured, the holes are slightly bigger, which makes them easier to work with, and the quality of the adhesive behind the copper pad means that if you try reusing or refitting parts, they're less likely to peel off under the soldering iron. Again, WTF is one of those things that comes to mind there.
It just reminded me with that, we used to use that for development stuff, and a 4 or 5 mil drill bit was your best friend to go through and break tracks.
Yes,
with.
the Vero board, yes.
Yeah.
Because who could afford the proper Vero tool that was designed to do that and cost, what, 20...
Or a countersunk
Which-
head or
which-
whatever it is.
Which was just a drill.
But a lovely handle on the end, come on.
Correct.
Anyway, as time went by and I got more money, I could get my hands on better tools and so things. And one of the things I found was a lovely piece of software called Eagle PCB. I'm sure many people here have seen that. Basically, this is the area of getting good quality CAD software, or CAE software, I guess you'd call it. Run on your PC at home, and subject limitations, you could design circuit boards and then you could go and do the whole press and peel stuff at home or even fab things out. I've done some press and peel stuff recently, not as pretty as Justin's. Here's the peel off for one. You'll notice there's a mix of blue there and black. The blue is, of course, the stuff that didn't get laser toner on it. The black is where I failed to clean the board properly. I was soldering it onto, so instead of sticking to the board and finding a nice place of protection from etching, I had to go through with my Dalo pen. I have, however, found in past that it's worthwhile keeping an eye on the bargain bins at your supermarket. You find often they'll put the little bottles of cheap, nasty nail polish in there. That works quite well as well. And when you're cleaning your circuit boards, one of the best things I've found to strip them clean is acetone. Not only does it take care of the nail polish, it also takes care of the laser toner, and it comes off basically with one wipe. And the smell's a bit noxious, but I mean, this seems to be about noxious chemicals, so par for the course.
Just move from that to the ferric chloride.
Invest in a face mask first. That's probably the...
Yeah.
Safety advice.
or a fan.
Although, to balance things out against ferric chloride, ammonium persulphate also eats denim. Ask me later how I know that. WTF.
You don't even want to get it on you.
And not only does it eat it, it makes the holes bigger as you progressively wash things. So don't think you've got to worry about light damage. It just gets worse.
Yeah, Ferric Chloride's not too bad. It only stains denim. Correct. Doesn't.
That's a
hit through it.
fashion statement, although I guess
Yeah.
holes are as well these
I
days.
wrecked
So
a few pairs of jeans
That's tie
over
dye.
the time.
anyway,
It's designer these days.
that's the
It went orange.
that's the press and peel.
Yellow.
This is what it made.
Fair enough.
It's a bit cleaner, again, thanks to liberal application of.
No, just lift the we're slowly moving the.
Ah.
Yes.
What's going on there?
I'm not quite sure.
Apologies for that.
WTF.
I'm sensing a theme here. Picking up on Hayden's suggestion about wire links and so forth. Again, making the stuff at home, double-sided boards are, I think, theoretically possible. Kudos to anybody who's done it at home. I just find it to be a nightmare. That board I've got there took me 3 goes of press and peel to get enough there. I felt worth going the next step because, I mean, despite wearing gloves and acetone and steel wool and wet and drying the boards, there's always some gunk that sticks behind and makes the image look rather rubbish. However, this board needed some topside tracks. So when designing in, I use KiCAD these days now because it doesn't have limits of Eagle PCB. Essentially what I did was make a 2-layer board, push as much tracks as I can onto the back of the board, doing topside tracks where possible, making sure they don't cross, and then not manufacturing topside of the board. Trick in KiCAD, you can change the size of the vires on the board. So simply going through the vires and making it the vire a bigger diameter, the hole a bigger diameter. Press and peel gives you pads you can then work with. In terms of, again, drilling holes, I've got a Proxon drill press at home. It's a small, I think they're designed for jewelers. And the nice thing about it, it's got very good bearings in it, so there's no eccentricity in the drill. So when it drills, it doesn't like try to trace a circle and snap the bits. So I'm now using a 0.8 drill bits and 0.8 mil drill bits, and they just survive beautifully. So if you think about a Christmas present or tax check thing, and you go down this path, a PCB drill is a good thing to have. Sadly, not available at JCAR, but I mean, maybe one day. Beyond making boards with press and peel, I've kind of become a bit of an addict with online fabrication for a couple of reasons. There's a board here somewhere, if I can find it, that Justin had up before. Let's try something light, makes it better. This board, basically, all things being said and done, it's a RS-232 level translator. Now, most people will be familiar with the Max 323 RS-232 buffer chips. You can buy those here in Oz in a friendly solder format for about $12 a piece. For some reason, the prices are rather high. That whole circuit board there, with all the components manufactured in China, cost me less than $12. That's including freight. So I got the level converter chip, I got 3 relays, there are some driver transistors, there's some power supply caps and other bits and pieces there, all manufactured by a robot in China, no hands on there, perfect surface mount soldering. I can't surface mount solder, I seem to lose parts on the board somewhere. Again, WTF being one of those things that comes through. This board, I guess, it's kind of a hybrid. It's a mix of parts you can see on the board there, but adding further parts of my own. There's a big socket there for effectively an Arduino on the top. Doing it that way because if the board turns out to be a problem, like that one there is a failed prototype, I can pull the Arduino off, put something different. Again, reuse parts and not waste money. Again, not a commercial provider. I've found that using companies like JLCPCB for me has been rather good, and it allows me to make things I can't make at home. I mean, issues regarding registration, double-sided boards. That board is a 4-layer board. It's 4 layers because they will do up to 6 layers for no different price to a 2-layer board. So I figured, why not use all the layers? It means you can do really greedy things like have a power plane, a ground plane, an east-west plane, a north-south plane, and route and via through. And subject to issues regarding trace limits and so forth, you can make some rather cool things in rather small packages. KiCAD really helps me in that area. I mean, there are other tools out there, of course. There are even web-based design solutions which run inside your web browser, so you can just basically go to a website, click on the link, and you're in the tool using it. Hayden mentioned Altium. That works in a web browser. I think it's EDA boards, another one out there.
Easy EDA integrates with JLCPCB.
Yeah, that's important because not only does it mean you're using CAD software to design your boards, you can populate it with parts from their parts catalogue. You can have them manufacture the boards for you. They can quote you on what you're building and give you a breakdown of the board costs, the part costs, assembly costs, freight costs.
All online. And assembly.
Yes,
Yep.
everything. So literally to make a board like those these days with those tools, it's PC, internet access and a credit card. Oh, and somewhere to deliver the parts to. Hint on that, check their shipping options. I live in New Norfolk, which is outside the Hobart CBD. If I use DHL or FedEx, it's the extra $30 in freight they won't charge me, which is basically what they charge you to deliver to Hobart. So there are other options out there. So pay attention to the billing, and you can find you can get boards really cheap, really well. What else is in my box of bits and pieces there?
I know what's happening there. It's just sort of having a bit of a...
Another feeling we've been on all the time. The other nice thing about JLCPCB is they not only makes your boards, or PCBWay for instance, they'll make other people's boards for you as well.
imagine drilling that.
Some old timers might recognise this.
S100.
Correct.
Hey, that's a prize. Who said that? You get a Protel manual.
Oh, I think I left that here last week.
Oh, did you? well, we also have the 5 1/4 inch Protel discs. Sorry.
The online manufacturer is worth keeping in mind if you see some kits or things people are doing out there which you think are rather cool and want to do yourself. There are a lot of open source projects where people not only put the software up on the internet for free, they put the Gerbers up there as well, so you can download them, go to your board manufacturer and say, make me some of these. I think Hayden had some AIO boards made a while back. AIC boards. They publish their boards online, so you can basically take the bill of materials and Gerber files and pay someone to make them for you. There are certainly some older versions, the digiboards out there people might be familiar with, for radio interfaces. They're out there where you can go and basically spin up yourself.
All of the voter boards on the repeater system were all made from a project that was made in like 2013, 2014, and it was basically submit to PCBWay and they just made the boards.
Yeah.
I think they cost like $10 landed.
Yeah, it's
not populated, but yeah.
So they're a double-sided board.
Yeah.
Plated through hole.
Yeah.
Yep.
Solder mask.
Yep.
Silk screen.
Cut to the right size.
Yep.
You can't go wrong.
There are, I think, the JLCPCB boards. They'll have 20 layers on a board. They'll do ceramic boards. They'll do aluminium boards.
Different colours. Screen colours. Yeah.
They will panelise your design, or you can use plugins to your CAD software to do that. By that, what I mean is, instead of having, there's a big sheet that Justin had here of a whole lot of images of circuit boards spread all over it. You can either use their tool or the KiCAD plugin and say, here's a board design. Give me a board, an output set of Gerber files, which is 3 across and 5 down, and with the right markings on the board, you can say to the manufacturer where you want the V grooves in the board, so you can snap them apart and break them down, do what you want with them. That's also quite cool when you consider that you can get the boards assembled with parts in that form factor as well, and that kind of assembly with a lot of smaller boards is why they can be made very, very cheaply. A lot of those Chinese modules you see on the net, for Arduino's bits and pieces, if you look at them very carefully, you'll see that the edges, they've been V-cut, and they're probably doing that to manufacture them and get the costs down. Again, it often doesn't affect the per board cost.
And PCBWay, at least, and a couple of the others too, you can give them a bill of materials like DigiKey or something, give them all the part numbers for DigiKey. They'll go and they'll order it all from DigiKey, assemble it all, take photos of it and say, are you happy with this? Then they will flow the solder, mount all the components, and even test the board for you.
Yep.
Before it actually arrives to you.
Why wouldn't
Which saves you hours.
Also, the actual CAD software itself. I know KiCAD has got a electrical rule check you can do on the schematic, which will go through and work out whether you've got pins that haven't been connected that should be connected, or your power routing doesn't go all the way through. A whole range of inbuilt rules around things to make sure that the schematic is logically consistent and is sensible. There are also electrical rule checks on the board. I might have these the wrong way around, where it'll go through and do things like, say, your tracks are too close, you need to move them apart so the boards can be manufactured, and a whole range of tests to make sure your board is as close as possible to be a manufacturable item. I think to date I've had, using those tools, no failures with any boards made by fabs in China. I had one manufacturer come back and say they weren't sure about a component rotation, that it was more a case of the part I was using, the footprint silk screen was not accurate, but the placement was. So I should basically just please follow the design and she'll be fine, and it was. So a lot of these quality control processes they have, which I think 20 years ago would be big iron, big country, big company type of things, you can go out there and basically use yourself as a hobbyist or small business person or a prototyping engineer and turn that stuff that looks really, really, really good. Again, it's the thing I like about this is it's like some people do Sudoku, some people do crosswords. I like routing boards and making them. It's just actually relaxing. I know I'm weird, WTF, whatever. I think it's pretty much everything I brought down. I guess anyone's got any questions?
Sean, earlier on you explained about using the 6 layers to do I think you said a ground, a power, the east and west. Can you explain what you're talking about?
Okay.
This is from someone who's only done single layer.
Starting example. One of the things I found in Eagle was the concept of ground plane, where basically you cover as much of the board with copper as you can. I do it for 2 reasons. A, I think it's rather cool, and B, it saves the amount of etchant I use, because leaving copper behind means you don't use a lot of etchant. Now, if you look how the board here stacked up, you've got 1 layer of fiberglass and 1 layer of copper. If you make a multi-layer board, what you typically got is an interleaving layer of non-conductive layers and conductive layers of copper in a stack like a sandwich. When you design the boards, what you can do is you can basically paint in simple case, a great big rectangle around the board and say, this mass of copper is a ground signal, part of the ground plane, part of the ground net list. You can put another layer in the stack and then draw the rectangle around there and say, this is going to be part of the 5-volt net, and go through and basically name up and associate those poured zones of copper with a net in a PCB. For those who don't understand, a net list is basically like a single collection of connections between the various components of the board. So if you're doing like a TTL based design, you'd have a 5-volt power supply and a ground plane. All those 5-volt connections will be in the 5-volt net, similar to the ground.
Yeah. It gets the net list from the schematic as well.
Correct.
So the signal net list comes from the schematic usually.
That's generally, I guess, a lot more complicated because there's more things going on there, because there's lots of only a couple of pins per net. If you wanted to be, I guess, lazy and the distance between the various connections in the net doesn't make sense to you, and you don't want to have that problem of how do I make sure my tracks don't cross, if you've got like a layer where all the tracks just go left to right or east to west across the circuit board, and another layer where they only go north, south or up to down, and they're on different layers in that board, they will by definition never make contact, they will never foul each other. It does mean you've got to start putting wires through these layers to connect them. So if you've got a diagonal connection, you might go from this pin across do a via down to the north-south layer, go down and connect it there. And it does mean you're putting a lot of vias in the board eventually.
Oh, right. So you're saying instead of, so like if you've got your ground,
Yep.
instead of having, oh, forget the ground, your 5 volts. So instead of having to route 5 volts all over the show, you just run a via down through the 5 volt. Ah.
Even better than that, if you're using through-hole parts, all those pins are effectively vias.
Yeah.
So if you've got, the first thing, if one of the early things in your board design is you put a 5 volt 5 volt plane through the board, every single component you place on the board with a 5 volt pin gets connected to that 5 volt plane. So you don't need to route it, it goes there directly. It's also a good way, I guess, of managing interference and current, current things going on inside the board.
So it's shielding.
Yes. I just like it because I'm lazy, and because if I'm making these boards at home, I save copper. I think Justin's got...
No. Sean talking about on one side it goes in the vertical, on the other side it goes on the horizontal. There's a classic example of it. If you turn it around or look through it, on this side most of it's going that way, and on this side most of it's going that way.
Yep.
So it's just an example of how you set that up. That's only a 2-layer board, and that's the actual board.
Yep.
And you'll notice a whole lot of wires on the back. Didn't quite get it right.
Bodges.
No, well and truly.
Oh,
Prototype.
yeah.
That's exactly what it is.
Or as I've done the odd time, go bugger that batch, put them in the spare part bin, fix it up and order some more.
No, well and truly.
But yeah, I mean, it's the thing I like about the fact that you're not constrained with just one layer of copper because you're not making these boards at home. It means you can start doing interesting things. You can make the boards physically smaller because you don't need real estate to wrap all the copper around.
Yep.
I mean, that board I made there, you can see up here, that's a 15 by 15 centimetre square board I got from JCar. That was tough work squeezing down on the board, that just because I needed real estate to do all the copper links on top.
Prototype. Production. It's just, yeah.
So-
You let the software do the routing and...
Yeah, or several cups of coffee, sit back, relax, and what makes sense, what looks good. I mean, most of my stuff I make generally works but isn't pretty. This is one place I put an effort myself, just to make myself know that inside the case is something I actually like the look of. I guess I've stared at too many copies of ETI to go, that's a nice board, or Elector, which is one of my favourites. And again, it's the benefit of using these fab houses. It's the how many layers do you want on this and how many do you actually need. I find going beyond 4 boards right now is a challenge. I don't know what you use layers 5 and 6 for. You're doing things like multiple analog boards and so forth. You want different power planes and stuff. And again, you can often do things like have a board with 2 net pores which are separated but still do have different. Just use that one layer. It's fun. Keeps the grey matter ticking over, and I guess stops you going go. Well, if it's not already too late. Ron.
Sean, what does this board do? It can see it's got camera controller written on it.
Okay, I'm tinkering around with some cameras at home. They use a control protocol called Visca. Basically, it's an old-fashioned serial protocol that was developed, I think, by Sony, where you can tell a camera how to pan and tilt and focus and so forth. One of the cool things Visca does is lets you have a single serial connection and loop them through multiple cameras, and if each camera has a unique ID, you can talk to them without having to use multiple serial ports. This is a variation on that, where essentially what's doing is it's taking that incoming RS-232 stream with the camera IDs, rewriting them to be the same camera ID but mapping them out to an output port. So it thinks that I've got cameras 1 through 4 on the input. That's camera 1, 2, 3 and 4, but all the cameras get to think that's camera 1, camera 1, camera 1, camera 1. So you can change the connections and so forth without having to flip switches or reprogram cameras. The little board up here, that's a Teensy 4.0. There's a guy named PJRC who makes these effective. It's another Arduino board, but it runs at 700 megahertz and has more memory than I can work out how to use, and 6 serial ports on board, and does USB and other amazing things.
Now for another prize, that PCB that I handed around, what's missing on it? There were both sides of it. There was a component side and a solder side, but what was missing?
Where's the boards?
Somewhere back there. Where's the PCB?
The blue board.
Yeah, that's it.
You nodded
So
at
what's missing?
The case.
the box.
No, have a look at the PCB.
Is it missing all the wires or something, is it?
You get the prize.
Oh, gee, what did I get?
Protel manual.
Schematic.
Because what I handed around was the component side and the solder side. Here's the via printout. So this is also used for the drilling template. So that's why you need to put all three of them together to actually get the board. So yeah. Anyway, good stuff.
I guess someone's passing the press and peel around. If people are interested in playing with that stuff, it's damn thing. Let's stay up.
I think that might be why I was at the tip shop.
Didn't do this during testing. Come on, WTF?
Hasn't it got a tension adjuster at the bottom?
Tighten up the clutch.
No, it's got nothing to adjust at all. I think it's one of those things that does it till it stops. The press and peel that Justin mentioned, I think that when he bought it, he forgot to mention he was a Reast member.
Oh, yes.
I
Yes.
bought my second pack a couple of months ago. It was, I think, $40-something normally, but because I said I was a Reast member, when I bought it at JCAD, they gave me a discount, so you get, I think, the next
Correct. You get 10%.
quantity, well, next quantity break on whatever it happens to be. It's a often 10%, but can change. So it's talk to them. But certainly, if you're not a JCAR, one of their club members, just tell a member of Reast, and they'll give you that equivalent discount typically.
And if you
It's
go,
a trade discount versus a hobbyist discount.
no, correct.
Nerd Perks is not as good.
Yeah,
But it doesn't apply to every article.
correct.
I've been in lately and handed the card over. Oh yeah, right. Yes, they'll give you a trade on that. But there's been no reduction.
Yes,
Few items that are quarantined.
And it's $25 and over. So
yeah, as Rod mentioned, the discounts vary on the kind of item and quantity. So it's not like it's the typical, because it's a flat rate discount. But it's certainly worth asking for.
Oh,
I've bought
okay.
some top things there and been surprised. I got some I've thought, okay, that's a cup of coffee. I'm happy about that. So definitely give it a shot.
so that was $41 or whatever. Normally 45.
Yep.
So it's
I guess if I was going to say a takeaway was certainly what I'm seeing with a lot of these things here. If you've got the time and patience, have a good look at KiCAD. I pick out KiCAD because it's not web hosted, it runs on your PC, so you don't need an internet connection to use it. It runs on Windows, it runs on Linux, it runs on Mac OS. They're all equally tier 1 versions, so it's not like you get the second version or an old version if you use a different operating system. There are a lot of very good tutorials on YouTube on how to use it. It's been around for many years now, so there's a lot of content up there for the current version 8 plus older versions. If it looks like it's a intimidating package, I'd say get in slowly and focus on the easy bits. Probably the best thing I've found to get in there is look at the schematic capture, how to draw a circuit up. One of the things that I found was good about KiCAD compared to Eagle is let you do hierarchical or multi-sheet schematics. So you can break a design down into like the RF section, the logic section, the power section, put them on separate sheets so they don't have to confuse you when you go through and read them. And the drawings you come up with are very good. It's got a very good component library. That means essentially a lot of the symbols that you're looking for your schematic will be in there. Often the part you want to work with. So you've got a BD139, you add components such as BD139 and put it there, it'll mark it up and it will note. So if you want to later go into manufacturing a circuit board off it, it knows about things like the associated footprint if there's an exact match, or if it's a part that comes with multiple different kinds of packages like surface mount versus through power hole versus tagged or tagless. It'll let you say, okay, what footprint do you want that part, and ease in that. But the schematic capture alone, I think, makes it brilliant to be able to draw diagrams you come back to 2 weeks later and actually make sense of.
and that component includes all of the layers. So,
Yep.
so when you put that component onto the PCB, you get the silk screen for it, you get the right pad size for it, you get the right spacing for it, etc.,
Yep.
etc. So,
And some of the component definitions even include things like a link to the manufacturer's website where the data sheet is, so you can see what this part is and find out more about it. That alone I found was just, no more chicken scratchings or napkin sketches or things like that. They're digital, they're usable, and you can build on them moving forward. Beyond that, definitely look at the online tutorials. There's a range of them up there. They're often, you've got the choice of either like a 5-minute tutorial on one aspect versus going in deep dive. There's a very good channel by a guy called, I think Phil Samolny, called Phil's Lab. He does some rather long sections on actually making something in KiCAD. He also does Altium ones as well, where he goes through all the detail. So, sit back with something to snack on, a cup of coffee, and just watch and pause and think and give it a go. It may not make sense the first time through, but it's one of those things, the more you watch it, the more you do, the better you get. I've been using KiCAD now for 4 or 5 years. It's why it's my preferred tool, because I'm invested in it. I won't say it's the best thing out there, but it certainly works for me. Beyond that, ask members what they're using, check around, but it's just a fantastic way of turning ideas you would have done in the old days on a breadboard design into a commercial looking product with all the heavy lifting done by someone just for 20, 30, 50 bucks depending on what you're making. It's hard to say no.
Do they go as far as linking to a circuit library where you can say I want an oscillator, or I want a power filter, or I want an interface?
I haven't seen.
See sample circuits.
I haven't.
Tried in the.
I haven't seen anything there in terms of a KiCAD component. However, there are certainly plug-in modules people are writing or have written to extend what KiCAD can do. So I wouldn't say it's not beyond the realms of possibility someone may do something like that. You can certainly, it has the ability to go through and say, I want a new project based on this thing I did earlier. So nothing stops you from doing like an oscillator design and actually pulling this stuff in yourself. Again, being a computer program, you can copy and paste things from one schematic to another, from one project to another in KiCAD, and it'll drag through more than just the pretty pictures. Oh,
no, leave it there. Actually, looks good.
Yeah, rather than the top view, it looks more 3D.
Side view.
Sort of
actually, sorry, on that, one of the really cool things about KiCAD, another one of the things I quite like, it's got an inbuilt 3D viewer. So for where it's got components, where it's got a 3D image of it, let you go through and say, what should this look like if you actually made it? And it will render an image of your end product on screen with the board, with all your silk screen on it. If it knows about the parts, it shows the parts on there. Sadly, it doesn't trim the legs off things. I've used boards with like a red, 5mm LED. You show the LED on top and the legs sticking out the bottom of the board on the other side. It's very literal. Cool, but as a
It's like having it on a dolly.
It's amazing how it keeps it centered even though it's fallen over.
One of the things I've seen people use the commercial printing of PCBs for, which I think is really cool, is when people want a panel for the front of something.
Yes.
So there's no electronics, it's just the printing and the holes in exactly the right places.
And silk screening on.
I think the Nano VNA is an example. There's some cheaper versions that you can go out and buy. You look at it and basically it's like a sandwich of printed circuit boards with a display on the top, and it looks spectacular. There's another channel on YouTube, Curious Mark. Basically he and some other guys are doing a restoration program on a whole range of Apollo era electronics, so period correct bits and pieces. One of the sponsors they had was PCBWay, and they were making a control panel to replace something that they didn't have for a lunar lander. So they went to PCBWay and manufactured the control panel as a big PCB. So it was just a sheet with cutouts for switches and white lettering and so forth. So no intelligence or electronics, but it looked beautiful. And it was this lovely grey circuit board. I mean, I tend to not care about the colour of my boards, but you can get green, red, orange, black. I mean, it's
you choose.
It's just
what the solder mask
so is blue the colour of the month? Let's make a blue circuit board. How do you separate this version from the old version? Change the colour. And it-
You've definitely got support for KiCAD on the chat channel. Definitely. Craig's a KiCAD 8 cheer squad. Yes.
Yep. Thank you, Craig. It's agree with you.
Can you go through the pricing for these Chinese fabricators? It all seems very confusing to me, and they seem to want to fleece you on the freight at the end.
Okay. You're paying money for freight. It's generally done by...
Because you can buy other stuff from China, it costs nothing on freight.
Okay, there's a couple of... First, the issue you've got is weight affects cost of things out of China, and there's a threshold below. If it's less than a certain weight, they don't pay anything. So that tends to confuse things. Well, when it goes beyond a certain weight or volume or size, then they need to pay some level of commercial rates, and what you pay depends on, I guess, what service you're using. I think JLCPCB and maybe PCBWay like to know you've got the stuff that you're paying them for, so they're using couriers that are charging modern commercial rates. To give you an example, there's something. Okay. This is a work in progress I've got.
Do they sponsor you,
No,
Sean?
no, I don't.
'Cause
No.
everyone who's pushing them seems to be sponsored by them.
I'm not a YouTuber, so there's no money in them giving me stuff for free, and honestly with the discounts and so forth, I'm generally happy. This box you can see here came with 5 boards roughly that big. I guess to give it an idea of scale. I've got-
A few
Don't
components.
tell me you got a 20-cent piece in your pocket. Oh,
No.
God, I guess.
$1 coin. I got 5 of those boards manufactured. It took, I think, 12 days from here's my credit card to it was in my post box. Now, living in Norfolk, that does delay freight a bit. It cost me $38 to get the boards shipped from China to New Norfolk. That was using, I think it was SF freight rather than DHL and stuff, because they wanted more because they paid another courier to take from Hobart to New Norfolk. So I paid more than I'd expect to based on, like I say, buying the really, really cheap stuff in China. But once you get into you're paying a professional courier delivery stuff, that's about what I expect from one part of the world to the other in 10 to 12 days. And that's with tracking.
And you got components as well.
Oh, yeah. So that was $38 for the freight. I think
38, did you say?
$38 in freight.
And the boards themselves?
I think I got 5 of those boards manufactured. All the components you see there supplied and assembled. I think it was $60 or $70 all up. Now that is in part to me not thinking things through and making the board a bit smaller. If I'd made the board 5mm shorter, I could have panelized those, and that would have meant that instead of paying one board fee for one of those boards, I get 2 boards joined together for the price of one. But this is something, this is a work in progress. I was keen to get a version 1 because I got software to write for it, and I was at the point, do I keep on tweaking the design or just punch the button, order these things in and work out what I've got? And,
Now that's a courier service all the way.
yes.
I believe that some couriers have made an arrangement with Australia Post. You can use their drop boxes.
That was delivered to my PO box.
Right, but you can actually get it delivered to the post office in Newtown, the parcel pickup area. The red box is outside
Yeah.
on the walkway, and it comes out cheaper, I believe.
Possibly, but living in Norfolk, I'd rather coming to my house, to my neighbourhood where I can go to the post office, get a cup of coffee across the road and get back and... Ron?
Do you mind explaining what this board's for?
At this point in time, yes. This is something cool, but let's talk later.
Okay.
Work in progress.
So that was $67 for 5 boards
Yes.
with components.
Yes.
What approximately would it be without components?
So I've ordered boards before, and like 5 boards for $5, and then it was only.
And then $38.
No,
at the
like
end.
I don't know what I ticked, but I got the delivery for $2. So it might have been a special or something.
Yeah.
So I paid $7 for 5 boards, and I think obviously that's not populated, and they were quite small boards, but I just sort of went nuts. Like when I realised that, I just went, oh, what else? What other boards can I find and get printed?
But also weight is a factor, and I think there's a break point like 500 grams. The price goes up, and I think this is basically just crossed the line. So.
And how much did the new Norfolk add to the $38?
Because I used SF Express, it added nothing. So it's one of those things where they give you a whole range of options in terms of which courier service to use. I'd strongly recommend before you just go with the default, check each option and go, what does it mean in terms of the actual price, and double check before you go, I'll take it. But if you work in Hobart CBD, or you've got a post office in Hobart CBD, you should avoid that extra taking you out to the boonies or whatever.
But it's a steep threshold for $2 freight to $38 freight.
The couriers, I know from other stuff I bought online, when I buy things freighted out by DHL bring the stuff to Hobart, and then they get another courier, not them, to do the last leg. And those guys want to be paid. It's just... Yeah.
Craig, VK7HH, said 10 LED backlight boards ended up costing me $5.20 populated and delivered after applying a new customer discount.
Yeah. They have lots of discount codes, certainly JLCPCB. I think PCBWay does the same thing as well. I think it's a part of a lot of Chinese e-commerce. They like you coming back and offer you discounts to come spend more money. So just watch those codes and be careful when you buy and use them before they expire, that kind of stuff. I know they suck you in, and for me this is fun, not a job. So I'm willing to spend a bit more money, have a good time. If it works, even better. If not, WTF.
The local courier situation is a bit variable too. Australia Post. The posties are now delivering small parcels up to that size of that box as part of their letter delivery, so that don't need a courier as such for that. Other situations, you'll see a courier arrive and he's subcontracted for Australia Post, and you're trying to work out why. It could have come in a small box, it could have even come with the postie, it was small enough. So anyway, you don't know. But just the other day, my daughter was expecting a parcel, and it ended up being that it was TNT. She got a message to say that it had been delivered. No. When she got home, no parcel whatsoever, no note, and she had to go chasing. We now know that it hasn't been delivered, even though we sent you a message to say that it was, but we're not quite sure where it's gone. But it'll be here. You can come and pick it up from our depot Monday to Friday, 9:30 to 4.
Yeah, they don't want to deliver it to your house. It's going to cost too much money. The stuff like this I've got from China, I've generally looked for and picked, I think it's SF Express on the list, and I've had nothing lost. The tracking on their website has been excellent. At times it's been in Chinese, but I mean Google Translate does a good job with that. And typically I've found with, again, stuff that takes 2 or 3 weeks to get here, they're updating tracking details at least on a daily basis, so you know where things are. And again, that their strike rate has been excellent. Nothing's been lost, and typically I figure when I go, here's my credit card number, make it happen. 10 or 12 days later, it turns up.
Anything that you'd like to input into the process? Your experience with the Chinese manufacturers, or any other experience you've had with PCB manufacture? Right.
So I had not heard.
Close speaking microphone.
Yeah, the press and peel, I had not heard of that before.
Okay.
And I remember reading an article in the magazine that you can actually, and I have done it, just use ordinary paper in the
Correct.
in the printer, laser printer. Make sure the board's really clean using acetone and all that, and preheat it, get it nice and warm, put the paper on and use the iron. And I've happened to make boards like that. You might need to touch up a few areas with the pen if it's a bit thin, but that works without the expense of the...
and exactly the same. You're heating up the toner and transferring the toner onto the board.
Yes.
That's what
Yeah.
you do.
I think there's another method I've seen people talk about. Mike here, I think we're okay.
No, you've got one. Yeah.
People have reported doing a similar kind of trick but using just ordinary paper and using a mix of acetone and isopropyl alcohol. The idea being that you scrub the board perfectly clean, you put the printed paper down with the toner side down top of the copper, and you wash the board with this mix. And the theory is the acetone in the solution dissolves the toner, the isopropyl alcohol helps release through the paper, and the toner wants to stick to the copper more than the paper. It sounds a bit interesting, but again, the ingredients aren't particularly expensive. I mean, you can buy acetone and iso from your hardware store and give it a shot. You're not using $5 sheets of press and peel. You don't need an iron, and if you make a mess, I guess you can always hide it somewhere, not worry, and go to plan B. I like the commercial boards, and I still make the occasion stuff with press and peel because that was like here, it's just a one-off. I'm not going to make 5 of these things, and the online fab shops will often ask you for a minimum order. So if you want a board, you're going to pay for 5. So just deal with that, or be cheap like me and waste more time than you probably should have in the first place. I think Justin mentioned using UV film before. One option I've seen people use is basically getting sensitized film on clean copper and then using a blue light to selectively expose it to harden the resist so the rest can be washed away.
Ultraviolet light?
Different mixtures use different light. That's the...
But from what I'm seeing, it's a trade-off between the wavelength you're actually using and how long it takes to expose it. So not using quite the right colour blue can be corrected by simply exposing it for longer. I mean, people have used sunlight, I think, with good effect. I think my first exposure box was a 3-foot blacklight tube, which, again, eventually went to the tip because its usefulness didn't justify the space it took up in my shed. One method I'm keen to try at some point in time is black spray paint. Basically, the way this one works is you scrub the board perfectly clean, and when it's nice and dry, you put a coat of black spray paint over the top. And then when it's time to remove the paint, you use a blue laser engraver and basically burn off the paint you want to get rid of. And then you leave the remaining paint on there as a protecting cover and etch the copper away.
Actually, that's a good point. There is another way of doing it. If you have a router, a 3D router, you can actually route the copper off the board. I've seen that done as well. It's a bit messy, but it's another way of doing it.
I looked at that, but then I bought a $150 laser engraver off eBay. I thought that's a cheap entry and I can afford to do other things with it if it doesn't actually work. Those milling machine boards are fantastic, but they're messy, they're noisy, and they're a little bit expensive.
Yeah, there's a YouTube, if you want to dive down a rabbit hole, there's a YouTube of guys creating a valve computer.
Mm-hmm.
He routes all his boards.
Usagi Electric, fantastic channel.
Actually, I think it might have been you that put me onto it.
Sorry about that. You don't need to sleep anymore, do you?
3D printing onto the board.
Beg your pardon?
3D printer track onto the board.
That's been done. And again, if the board's clean enough so that you want the opposite of a 3D printer, you want a flat surface stuff will stick to rather than something that will release easily.
Yeah.
But logically, going through and covering the board with molten plastic and then using that as the surface protector, in theory, should work perfectly fine. It's one of those things boils down to how long you want to spend putting the board surface down. I mean, the laser engraver trick, I tried that just with a piece of cardboard at home to see what happened, just to see how long it take to etch, or rather to remove the copper. It's not very smart in that it wants to do basically left-right scan and and with the level of resolution there, it would take like half an hour to go off and do a 15 centimetre square area. So to my mind, it's probably, I hope it's very reliable, but it takes a lot of time to make it happen. I suspect the 3D printer would have the similar issue. How long does it actually go through to cover that area of the board to protect it from etching? Probably, again, the trick with that is, like I did with that board, it's you don't want to remove, actually no, not, this is the opposite of what you want, isn't it? You want to remove as much copper as possible and use as little 3D plastic on there, otherwise it's going to cost you a fortune in plastic to make a board. And again, you've got that trade-off between how long it's going to take, how good it's going to be, and what's it going to cost you to make the board.
One gotcha that Craig actually has mentioned here, which I've heard before, is using standard parts and limit the non-standard parts where the design allows. If you consolidate to common values where design allows, it saves a packet.
Yes. On the price of Chinese components, with JLCPCB, they have two kinds of components. They've got the basic parts and they've got extended parts. The basic parts are always on the robot, ready to place on whatever you're making. The extended parts, someone's got to go to the library, pull the reel out and mount it on the robot and then put it away when they're finished. And they charge a premium to use the non-basic parts. To give you an idea of price, that board I showed you earlier, the resistors I used in the relay drivers were less than 1 cent each. I think each non-standard part, if I'm using like non-standard relays there, they're going to charge me $1 to mount the reel of relays on the machine before it goes through and places them out. So the more you pick their basic parts in your boards, the less money you will spend on that assembly price and the cheaper the boards will be for you. The other option, I think Hayden mentioned it, you can get other parts added to your board, not from their library. I know PCBWay, for instance, you can actually not only just order parts from DigiKey or your preferred manufacturer, you can actually send the parts to them. But again, complicates the production of the boards, takes time. I think it's getting to the point you're doing something very special and you're probably getting to the point where better finding a club member here who can do service mount work and 6-pack of beer, can you solder these for me please?
And there'd be minimum numbers with that sort of stuff because they'd have to buy a reel of it and all of that sort of thing.
Although, again, one of the things I've seen them do, they have a stockpile of, I don't know what the term they use is, there are parts in their inventory that you can use to make your designs, and some people have their parts held in the fab shop. You can buy from them to use in your design. I think what's happening is people are preempting their designs by buying bulk parts and saying to JLC or whoever, hold these for me please, and then indenting that stock when it comes to manufacture, and with various changes in production sequences, I've got leftover parts, do you want to buy them from me instead? And a bit of horse trading there. I don't do anything that requires that kind of horse trading, but if I was making stuff with large board volumes and so forth, it'd be worth giving some thought to again, keep costs down.
So when you're using KiCAD to do your designs, is there some way that you can like import the standard part list from someone like JLCPCB, or do you just from experience know these are the bits that they're going to have?
That's I think a yes and no question. Out of the box, KiCAD knows nothing about JLCPCB. So typically what I do is I go to each part I use and add another attribute to the part that says here's the JLCPCB part number. I'll go through their online catalogue to work out have they got what I want, what quantity do they have on stock. If they've got none or small numbers, I'll probably avoid that part. What does it cost? I'll pick that one and put it there. Having said that, KiCAD supports a concept of plugins.
Yep.
There are plugins that will work with many board fab shops. For instance, I've got the JLCPCB one, which it's not the most advanced one out there, but it does let me to go through and generate my Gerber files and say, give me the files to JLCPCB to upload to, because that's a two-step process.
Yep.
There is a third-party plugin I've read of, which I haven't checked yet, which goes down the path you're talking about, where it actually talks to JLCPCB, it pulls down the inventory of parts and part numbers and so forth, and lets you look up inside KiCAD what's there that I can use for my design. But it's a bit of a research exercise, and again, the thing I've found is that the availability of parts is not guaranteed, because as people manufacture things, their part stock goes down. They seem to have a delay between when they run low and when they order more stock, so timing's important as well. So a lot of the design work you do is often a compromise between what you want to manufacture and what you think will be available when it's time to place the order with them.
Yep.
So it's a bit of guesswork, forward planning and finger crossing.
Yep.
Yes?
If we ever end up with a conflict with China, do you have an alternative supplier?
As a hobbyist, it's not a concern I'm worried about overly. I am aware there are other companies in Europe and the US that do similar work, but there is a price tag associated with that.
Correct.
And while I don't spend, I have no problem spending a bit of money on my hobbies, but I'm not stupid. I've got other vices to fund as well, so.
The PCB and the schematic application that I use is a thing called ExpressPCB and ExpressSchematic. It is created by a US company, US PCB manufacturer. I've never bought a board through them because it's too expensive. However, you can export the board to whatever, and in fact that's what I use with the press and peel. So the boards are designed in ExpressPCB and I just print them. But that's a US manufacturer and it's got the same sort of functionality. You can do a bill of materials. You can go, I want you to populate the board. I want you to do whatever.
Yeah.
But it also comes at a premium.
For me, KiCAD is vendor agnostic. It doesn't care who manufactures your stuff.
Correct.
People make plugins to make it easier to go down that path of a particular vendor, but you're not locked in. And none of those manufacturers can stop me from using KiCAD to do whatever I want with another vendor. Given the US is doing a lot of investment in infrastructure work right now, they've got the CHIPS Act in place. We're looking at onshoring semiconductor manufacture. I wouldn't be surprised if we see more of these kind of fab houses spinning up in the US and them using sovereignty and IP security as a reason to invest in those facilities in the US and maybe bring the price down. And I'm certainly not against using them to try to see what they can produce and how good their products are. It'll be very interesting. I think interesting times is the phrase.
When you get these boards pre-populated for you, are the parts labelled as to what they are, or have you just got a board that could be anything?
The parts are labelled as they come from the manufacturer. So if they're using TI parts, you could buy the same parts from, say, Element 14 or DigiKey or Mouser. They're not using no name or clean components as far as I can see. There are some parts which they don't label because it makes no sense. Just the resistors are 0604, so that means it's 0.06 inches by 0.04 inches.
Freaking small.
So you can't they're just they're resistors. They look like capacitors. They're just too small to write on. But certainly, I've got no reason to believe at this point in time the stuff I'm getting from them is counterfeit or in any way a questionable supply. Certainly their online parts library lists the manufacturer of the parts. As you'd expect, many of their basic parts are manufactured by Chinese companies, but I've had nothing made by them which has not performed as I would expect. Similarly, there are TI parts and other companies out there that you fab elsewhere, they're the same stuff.
Yeah.
I think they understand if they play games with a dodgy supply chain or counterfeit parts, it can do nothing but harm them.
There are some places who put out either complete items, TVs, video recorders, whatever. Not that you've got video recorder these days, but a complete object. You open it up, could be a bucket of sand. There's no labels on anything.
I don't know why they do that. It just seems to be pointless.
Throwaway item.
But removing part markings, to my mind, is a retrograde thing because A, it undermines people's confidence in the products, and B, it doesn't really slow down people reverse engineering what they've manufactured. I mean, one of the classic examples I think of is the Quansheng handhelds that I think many of us here have. Someone's already gone through and reverse engineered the design. You can get online, you can get the KiCAD schematics for the circuit board and the full bill of materials, and you can make your own. You couldn't make them for the same price you can buy them because they get 10,000 of these things made. Well, unless you want to mortgage the house and build 10,000 dodgy Quanshangs, in which case, yeah, don't know why you do that. But people are getting very, very good these days at working out what's under the hood. Many parts, like you say, they're often standardised. You can work out what's around them. Will let you know what's they actually do. And I think China's slightly realising that transparency is actually a commercial advantage to have these days. Mystery parts, I mean, well, having said that, we see mystery parts in how many Japanese radios you have with like a Yaesu chip or a ICOM chip, and what's inside it, you don't know. They manufacture it themselves. It's almost the same thing. It's not fake, it's just a mystery object.
You get a lot of situations where manufacturers will get a particular part, like a standard transistor, but they'll put their own part number on it. And they specify with the supplier, I want it with this part number on it, so that nobody can figure out what it is.
And
not common.
Yep.
So some of the guidance and control boards that they must be developing in Ukraine and places like that, they're probably getting 100 or 1,000 done at a time out of China.
Potentially, if they're smart, they'll probably get them made in the US and spend US government money and US companies to manufacture things to send to Ukraine. That's what I do personally. I think one of the things we saw was when the drone war was in its early days. If you wanted to buy parts to build a drone on AliExpress, I thought, best of luck to you. People would buy these things up and stuff became very difficult to buy because other people had more pressing need and bought the whole stock. I mean, would you, if you were doing that, don't buy things from China if you were afraid they might actually lend to their friends in Russia?
Any other questions? Comments? One comment from Craig, like all designs though, parametric search, find JLCB part number or alternative modified design if needed.
Definitely the last point. Done that.
All right, well and truly. Well and truly.
What's going on?
Not sure. Need to wedge something in the... yes, that's probably better. Bit of counterbalance.
I think it does more than just count. I think it locks it in place.
There you go.
Hiding in plain sight.
There you go.
Figure that out at the end of the presentation.
Do you remember me saying that, yeah, the WTF phrase? It's like,
Yeah.
welcome to
It's
my
on the
world.
screen. It's on the screen, Steve. Yeah. That's good. All right. I hope you've got something out of it. Please come up, have a look, up close and personal if you want to, or ask questions. And it's all online as of us finishing. So if you've missed something, you can go back and have a look at it.
And
So,
I'll say it again. If you've got the spare time, have a very close look at KiCAD. You might be surprised what you can get for nothing.
well and truly. All right. Cool.
And it's much better than that easy EDA.
I've never used Easy EDA, so I can't say. Also, I've got a lot of time invested in KiCAD, so Easy's is relative.
So we'll come to you for questions.
Yeah.
Cool. Thanks very much. Cheers.